Hi everyone, so we looked at Chaetognaths, and in layman's terms, these are scary looking worms with hooks on their mouths. And there is a look at the fearsome fella. Chaetognaths are the ultimate angsty creatures. Although they can be as little as 1 millimeter, they can get up to 15 centimeters. And the thing about them is that they will attack and eat other Chaetognaths of their own species, which is other zooplankton, as well as even attempt to eat baby fish. And the thing with that is baby fish can be about a dozen times larger than they are. But usually, Chaetognaths are about 30% the size of their prey. So that is a little bit of a Napoleon complex if you ask me. But even with their tiny stature, they are viewed as one of the most important consumers within their niches. So some background information on Chaetognaths: they have a transparent body, they are hermaphroditic, and they have multiple body systems, including the circulatory, nervous, and excretory system. They're sometimes known as arrowworms because of their caudal fins, as well as the 2 sets of lateral fins that they have. And they primarily prey on copepods by detecting vibrations using the hair on their heads. And they then use their sharp teeth to grab the prey and inject toxins that will immobilize them. There are about 100 species of Chaetognaths known. They enjoy polar water and are typically found in the deep sea of the Indo-Pacific region. And the thing with Chaetognaths is that they don't fossilize well, and so it's difficult to make certain assumptions of the fossil record, so that's stumped scientists along the way. So in the research article that we chose, it was written in 2010 by 3 scientists, Cruz, Bray, and Bathman. And what they did is they studied the role of midwater Chaetognaths in the Southern Ocean pelagic energy flow. And the purpose of this study was to quantify the ecological impact of the Antarctic midwater Chaetognaths by combining 1. Field data on abundance and body mass with 2. General Chaetognath respiration models derived from previous published data, and 3. Published relationships between respiration, production, and consumption in Chaetognaths. The research basically looks at the role that Chaetognaths have in the Antarctic Ocean, taking into account how they will move to different depths of the ocean depending on the time of the year / the temperature of the water, and how this affects the different trophic levels of the ocean. The scientists looked at different factors including biomass and respiration rates, and different primary production rates regarding what percentage of the copepods are needed to be used as food for the Chaetognaths. The scientists estimated that the net primary production rate of these copepods would need to be about 2.8%. If just looking at herbivorous copepods, it would jump up to 6.1% if considering herbivorous and carnivorous copepods combined. And looking at the whole water column, Chaetognath consumption is 7.1% and 15.5% respectively. So all of this information of the results summed up was just that the number of copepods increased as the depth in the ocean increased due to seasonal downward migration and production rates increasing as you go down. In the upper 300 meters of the Atlantic sector of the Southern Ocean, Chaetognaths comprise up to 30% of zooplankton abundance and biomass, and 39% of total Chaetognath biomass is situated usually in the Meso and Baylee pelagic realm, with biomass decreasing with depth and being higher in the winter than in the summer. It was found that there is a negative effect of water depth on respiration. This finding remains slightly unclear on whether it's from residual temperature effect, true physiological adaptation, or just an artifact. And the relationship, like we said, remains kind of a topic of debate. The respiration rates are also influenced by feeding patterns. Rates are lower in the starving Chaetognaths than they are in the non-starving worms. And in the winter, these copepods are more abundant at greater depths, like we said, due to seasonal migration, and they play a significant role as consumers in the environment. And so just overall, mesopelagic zooplankton in Antarctic waters play a very significant role in energy transfer from primary production to higher trophic levels. They're still puzzling scientists today due to their array of characteristics that seem to pick and choose from different clades and classes. This includes having a cuticle, which provides extra protection for the Chaetognath, recently being determined as a protostome when they were previously thought to be deuterostomes, and many other traits that are constantly calling for a shift of where they stand on a phylogenetic tree. According to the research, the single-digit and teen numbers that we talked about before might not seem like much, but the contribution to the overall energy flow in the system is very crucial. It might not be necessarily a keystone species, but it's close enough. The system would be highly disrupted without them. These are organisms that are without any fear. They attack others of their kind, even baby fish, that are tens and tens of times bigger than they are, and this is definitely a class of organisms to keep your interest.